Hello, today we're working on a mass stoichiometry problem from the ALEKS homework system. So the problem states, green plants use light from the sun to drive photosynthesis. Photosynthesis is a chemical reaction in which water, H2O, and carbon dioxide, CO2, chemically react to form the simple sugar glucose, C6H12O6, and oxygen gas. What mass of simple sugar glucose is produced by the reaction of 2.67 grams of carbon dioxide? Round your answer to 3 significant digits. All right, so we're trying to find, let's go ahead and first start out by just asking what is the question telling us to find. And the question is asking us specifically what mass of simple sugar glucose is produced by the reaction. So what mass, we're going to probably calculate that in grams unless it says differently. Of the sugar glucose, it told us what that was up here, is produced by the reaction of 2.67 grams of carbon dioxide. So I like to work from left to right on my page. So I'm going to get that my final answer needs to be the grams of C6H12O6 that's produced by the reaction of 2.67 grams of carbon dioxide. So I'm going to need to use this information to find this information. So then I need to start collecting the information that might get me there. So when we're doing mass stoichiometry, one main thing that we need to know is molar masses. So I'll need to know the molar masses of CO2 and the molar mass of glucose. So to do this, we would look on our periodic table and add up, of course, the masses of each of the chemicals in our problem. Those I've already got for us here today. So the mass of CO2 is 44.0096 grams of CO2 per each mole of CO2. And I'm going to recommend that you write it like this, grams of CO2 per a mole of CO2, because that writes it out as a conversion or as a ratio, which is how we're going to actually use it in our problem. The molar mass of glucose then is 180.1566 grams of C6H12O6 per each mole of C6H12O6. And remember, we don't write it in on the bottom of a fraction usually, but this is understood to be per 1 mole of CO2, or that many grams per 1 mole of C6H12O6. There's one more thing that we'll need for any type of stoichiometry problem, stoichiometry being dealing with quantities in a chemical reaction, and that is the mole ratio or the reaction ratio that we're going to get from the chemical equation. But wait a minute, we weren't given a chemical equation in this problem, which stinks, but we can deal with this. We need to work out what the chemical equation is ourselves, which is no problem because they actually tell us about the chemical reaction very directly. They say that the reaction has water and carbon dioxide reacting to form. So when you ever see the word to form or to produce, that means that's where the arrow is going to go in our chemical equation. So this plus this react to form this plus this. So we can go ahead and write that in. H2O plus CO2 react to form C6H12O6 and O2. Now we can go through and put them in states, but we don't actually need to here because the only thing we're really looking for here is the mole ratio. So we can save ourselves a bit of time and just write out the equation, and then the one last thing that we really must do is balance the chemical equation. And let me change that really quick. That's C6H12 to be very clear, H12O6. All right, so to balance the chemical equation, we just go back and forth. There's 6 carbons, so we're going to need 6 carbons over here. There are 12 hydrogens here, so we're going to need 12 hydrogens here. To get 12, we do 6. 6 times 2 is 12. Then oxygens. 6 times 2 is 12, 6 times 1 is 6, so 6 plus 12 is 18 total oxygens. To get 18 total oxygens on this side, we already have 6, which means we need 12 more. 6 times 2 is 12. So there we have it. The mole ratio that we need is the one between the carbon dioxide that we began with and the glucose that we're ending with. So there's 6 moles of carbon dioxide react to form 1 mole of C6H12O6. Alright, so let's go ahead and begin. Actually, we'll write that ratio down here. 6 moles of CO2 react to form 1 mole of C6H12O6. Now we just need to apply these conversions one at a time in a way that will get us from carbon dioxide to glucose. So the very first one is we need to convert from grams to moles of carbon dioxide. The molar mass of carbon dioxide is 44.096 grams per mole. So it's 44.0096 grams of CO2 per 1 mole of CO2. And that completes the first conversion. We need to make sure that the grams part of this ratio is on the bottom so that the grams will cancel. And our new unit that we've converted to is moles of CO2. We can then use the mole ratio. 6 moles of CO2 produce 1 mole of C6H12O6. 6 moles of carbon dioxide to 1 mole of C6H12O6. Now the moles of carbon dioxide have canceled, and we're going to grams. Or now we need to convert from moles of glucose to grams of glucose, which is what we need in the end. And that ratio is 180.1566 grams of glucose per 1 mole of glucose. Notice since I have moles here, the moles unit is the one that needs to go on the bottom. So on the bottom we'll put this half of the ratio. 1 mole of C6H12O6 goes on the bottom, and on the top 180.1566 grams of C6H12O6. Then we can plug that into our calculator. Just make sure you multiply by everything on the top, divide by everything on the bottom. Some people like to put it in as 2.67 grams times 180.1566 divided by, and then make sure you put the parentheses around 44.096 times 6 moles. Otherwise, you would need to make sure you punch the divided sign each time. So you do 2.67 times 180.1566 divided by 44, and then again divided by 6 when you plug it into your calculator. So make sure that you do that correctly, and then you should get, for this particular problem, 1.82 grams of C6H12O6. You can plug these numbers in to actually make sure that you're using your calculator correctly before you go on and do problems on your own. And that concludes the information today of how to solve this problem. Again, I recommend that you start off by writing down what you're trying to find, what the given information in the problem is, then collect your additional information, your conversion factors that you'll need to complete the problem, to work from what you were given to what you're trying to find, and then go about actually solving the problem. Thank you very much.